Yeah, very good evening. Hello, everyone. Yeah, good evening. So let's start with the OOPS technology here. Good evening, good evening. Okay. So we are starting with the OOPS technology. I had told it to you last time also, what is an OOPS technology and how to work with it. So let me tell you. OOPS is basically one of the concepts. Okay. So here, I had told you about the OOPS technology. OOPS stands for Object-Oriented Programming Technology. Where object-oriented programming technology means we are providing the safety, security, and encapsulation and modularization to the code here. It has also one more feature, inheritance. It means we provide the safety, we provide the security to our code, we provide the encapsulation. It means my code is secure. We provide the modularity. It means we are making the functions, and also we are going to make the inheritance. So all these properties are present inside the object-oriented programming technology. Okay, why it is there? Because I had told you earlier was C there and then C++ was there. So during the C++ OOPS concept was created, and in the C++ era, as OOPS concept was created and used, so here Python is based on C and C++. So Python inherits all the properties of C++ and C as well. So that's why we can work with the OOPS technology. In Python, everything is a object-oriented programming technologies here. Good evening. I'm fine. I'm fine here. Okay. So when we talk about the OOPS technology here, we need to write the classes here. Class, and you have to write the class name. Okay, you have to write the class name. Inside the class name, you have to write here attributes. Attributes are variables. Okay, and member methods. You can call this attribute as the member attributes also. Member attributes and member methods here, you can call it. We can make our class protected because these all data are directly protected. Now, how? If we want to access all the elements of member attributes or member methods, which are functions also, how can I access? I am dependent on the object. I need to make the object or instance of the class. How can I do that process? Simply, I need to give the class name, and here I need to make the object 1. So suppose here object 1, then only with the help of object 1 dot variable name I can give it, or object 1 dot function name I can give it here. Okay, that is there. So basically, class name and variable name or class name or function name I have to give it. Got it? In case of classes here. How to write the code? So let me tell you how to write the code here. So first of all, whenever I'm going to write the code here, I need to write here class. Suppose class student, here I'm making it. Okay. So here, suppose here class student, I'm taking a roll number, name, and age. Simple things I'm going to take it here. So I'm going to take 3 variables. How? I'm going to take roll number, name, and age. This much I'm going to take it. So how I'm going to take that? After class student, I need to initialize this name also, roll number, name, and age also. So what I will do, just wait here. Just wait here. So what I will do here, I will be writing one function definition here. These are the variables. These are the member attributes I'm going to take. So here I'm going to write a function definition, which is going to start with the DEF. DEF. I'm going to put certain values into roll number, name, and age. So that I'm going to do with the initialization function. So underscore initialization function is there. Now, what is this? Initialization function is a constructor which is going to give the values of roll number, name, and age. So in this way, I need to write the initialization function or constructor. Then I have to give a keyword self here, self. Then roll number, name, and age I have to give it. Okay. So once I will be writing it here, then now what is self here? Self is the object name. Object name. I have to write it. So student, let me write a code first, and then I will be explaining you entirely how this code is working. Okay. So first of all, let me write a code. Let me show you how the things works so that it could be much more better for you to understand how I need to write a code. Just wait here. Wait, just a moment, wait. Here. So, oops concept it is. So here I'm writing. Class is a keyword. Here I need to give a class name. So here I'm writing student. Student is a name of the class. Then here I'm going to write a initialization constructor, which will be giving the values of roll number, name, and age. Let me write it entirely, then I'll be explaining how this is working. So please give me a time to write the code here. DEF. Here I need to write underscore, INIT, underscore. This one is the initialization constructor. Here I need to give 3 variables that are the data members. So here I'm going to give them like here, here I'm going to give them as a self I'm going to give. Self is the object name itself or instance name itself. It is there. Then here I'm going to give roll number. Then 3 variables I told you, name and then age. Simple things here I'm going to take it. Done. Once I had written it, now I have to give the values of roll number, name, and age. What is the code I have to write? I'm saying self dot roll number is equal to roll number. Self dot name is equal to name. Then self dot age is equal to age. DEF, I'll be explaining you this code. You need to wait it first. Wait, please. DEF, here I need to display the data. So this one is the second function or member method I'm going to make it here. I'm going to pass self here. Hi, I'm just writing here print. Just wait. It is roll number now. So, wait. Here it should be. Roll number is equal to. So here I need to give the value of this self.roll, but this one I need to give it here. So self, I will tell you what is the self. Self is the object name itself. So object self dot roll number. Okay. Then comma, I need to write here. I can write it into second line also, okay, doesn't matter. Here I'm going to write it. Name is equal to, then comma, done. Then, see, I had constructed a class. So this one is a blueprint, just a blueprint. This is an architecture I developed for the class. Now I have to build on the memory also. So right now, just I created a structure. Now I need to build on the lay down the student class onto the memory also. How can I do that? I need to write the object name. So object name. So here I'm going to write, just wait. Object instance creation, I'm going to do it. Object or instance creation. So how you're going to do that? You are writing a stud1 is equal to student. Same name of the class I have to take it. Student class I had did it now above. So same name I had to take it. This class I have to take it. Same here. Then here, at the time of creation of stud1, I need to put some data here. The data will be related with the roll number, name, and age. So let me take out the roll number. Let's take a roll number here. I'm taking 101 is the roll number. Any name here I can take, such as Andrew name, and age here I'm taking, such as 12 years. Done. So this was the student details here. I'm sending it. Then I want to see it. So student1.display method here I'm going to take it. So without stud1, I cannot access any of these details. No, it is not possible. I'm running it. Here it is going to show me the data. I'll explain you in detail now. What is this method here? I'm constructing this initialization. Let me tell you. I'm making a comment. Initialization constructor is a default constructor, which is going to construct the values, basically. Let me tell you in detail now. See here. So here you can see, suppose I had created this entire class. Okay. And this one is, I'm laying down the class in memory. So here, this stud1 is the object name. Stud1 is the object name here I'm taking. Okay. Now what happens? What is the impact coming here? See, this method, initialization method, this is the method initialization method. This is going to be invoked automatically at the time of creation of constructor. When this constructor I'm going to make, this initialization will be automatically called. I'm not calling, automatically called. So when I'm running it, so this stud1 is going to be passed here inside the self. So self is the name of the object itself. Now, inside self, automatically stud1 will come. Then, inside roll number, this 101 will be passed. Okay. So inside roll number, 101 values will be passed. Andrew will be passed automatically in name. And this 12 will be passed in age. Automatically, you are not passing, automatically it is passing. So whenever I make the object, automatically initialization constructor will be called. This will be called automatically. Okay, let me tell you here now. You think it's student, suppose When I had written this code, now this line I had written it here, what is the impact coming on memory? In RAM memory, stud1 is created onto the RAM. But here you can see that roll number, name, age. Roll number, name, and age. Roll number, name, and age. These are blank. Now, what will happen when this code is written? This will be blank. Roll number, name, and age is blank. Now, what happens if it will remain blank? Okay. If it will remain blank. Okay. So what will happen? If this will remain blank, so here some junk values will come. In roll number, name, and age, some junk values will come. Any values will be coming. So when junk values will be coming, so what will happen? They will not take a proper values. So we want to give some values in roll number, name, and age because they are blank. So I am passing these values at the time of creation. So what will happen when I am just going to create this stud1? So stud1 is going to trigger this initialization constructor. Okay. And when this initialization constructor is going to be triggered, what will happen here? This value of 101 of roll number will be passed here. Andrew will be passed in name. And age will be passed in 12. Now what will come into self? This stud1 name of a object will be automatically passed here. Automatically. You are not going to pass anything, automatically will be passed here. Because this stud1 will automatically trigger this initialization constructor automatically. Now, what will be the impact coming of this roll number, name, and age? Because right now everything is blank. I want to fill with the values. So this roll number, when this line will be executed, self.roll number. Self.roll number means, what is the self value? Stud1. So it means automatically self will be changed to stud1. Stud1.roll number is equal to roll number. So this value will be passed here. So it means stud1.roll number is equal to 101 will be written here automatically. You are not writing, in the back end it is writing. Then inside the self, stud1.name, stud1.name, because inside self, stud1 will come. So stud1.name will be coming into this name. So this name Andrew will be passed inside stud1.name. So stud1.name will be taking the values of Andrew automatically. Then this age value is going to be passed. This age value is going to be passed here inside stud1.age. So this will be filled with 12. So the point is here, all the three values will be filled in with the data which you had passed. Done. Now what will happen next? Next, it is going to capture these values. When I had called stud1.display method, it means I am calling object name dot display method. I can never call any method inside the class directly. I can only call with the object name or instance name. Here I'm going to call stud1.display. So what will happen here? It will come and it will come to trigger this display method. Automatically inside the self stud1 will pass automatically. You are not going to do automatically passed. Then here it will be checking it out. What is the self.roll number? Here it will check it out. Self.roll number is 101. So this value it is going to take. So roll number is equal to 101. It is going to take. Next, inside the name self.name. So here inside the self name, here Andrew is going to be taken from here. So Andrew will be taken from here. And then this age will be taken here, self.age. So it means stud1.name, stud1.age, stud1.roll number will be captured and they are here. So in this way, it is going to work. Okay, so automatically this initialization constructor is going to be triggered automatically with the help of object name. So this is the detail I just took with the first student. Now suppose here you think I want to take the details of the second student. So what I will do for taking the details of the second student, I need to make another object. I need to make the another object. How can I do that? For making the another object, only here, I need to write student2 is equal to, so object name here I'm creating, object or instance name here I'm creating stud2, and here I'm creating this one here. No, directly we cannot write here stud. No, we cannot write there. Good question, but we cannot write it actually. Directly stud, we are not writing it here. We are using the entire classes because inside Python, everything is a class-based. Everything is an object-based inside Python. You had used a string now, string functions you had used. You had called string.upper, string.lower, and so many things you used. That is entire class-based. That one is an object-based. Inside Python, everything is a class-based and object-based. That's why we are using the classes here. If I want to write here stud2, it means if I want to make the data entry of student2, so in this way I need to write here stud2. Then here I'm going to create an instance or object, the name of the class, and here I need to pass the another student roll number. So 102 is the another student roll number. Then here, suppose John is the name of the student, and here, let's say 15 is the age. So in this way, I can pass on the new values. And here, if I want to see the details of the second student, so I need to call the display method with the help of object name dot display method. So object name dot member variable, object name dot method. In this way, I can work with the class. Directly, I cannot write anything. So here, I'm just calling it here. So if I'm going to run this code, so here it is going to give you the details of the second student, John. Now, how it is going to work here in the backend, how it is working into the memory. So what will happen into the memory? A second object is being created here. No? In the memory, stud2 will be created, but its roll number, name, and age stud roll number and age will be blank here. So how? Inside the self here, now what will happen as soon as just you need to check out this code and this code, these two codes here. This code and this code. So as soon as I'm going to write here stud2 now, and here I'm writing this line student and roll number, name, and age. So automatically this will initialize this initialization constructor, and itself stud2 will come. Directly, we will never write inside the self stud1 or stud2. No, you have to write the self. Self means object is, this class is calling object itself. Just like if I say, suppose I'm there, I say, this is my pen. What I'm saying, this is my pen, my. I will never say this is a Deepika pen. No. So here, self means object is calling itself. Class is calling the object itself. So that's why self is there. You can never write here stud1 or stud2. No, that is a mistake if you're writing it here. So I'm writing here stud2. Automatically, this 102 will be passed here into the roll number. John is passed here into name automatically, and 15 is passed into the age. Now what will happen? When self.roll number will execute it, so automatically stud2 will come. Stud2.roll number is equal to 102. So 102 will be filled up. Stud2 dot name will be filled up with John. So here John will be filled up. And here stud2 dot age will be filled up with 15. So 15 will be filled up. So here, cell.roll number will be, whenever I want to call this display, so I need to call object name dot method name. So I'm going to call the display method, automatically student 2 will come, student 2, and here it will be taking the value of cell.roll number, which is 102, then John, and then 15. And they all are displaying here. So it means this is a record of student 1, this one is a record of student 2. In Python, entire things are based on object classes, everything. So that's why we need to understand the concept. So conceptual understanding, you need to build it here. We can create the constructor once and we can reuse it multiple times. Automatically, initialization constructor will be called multiple times. As many as number of, as many as number of number of student details you are putting, automatically initialization constructor will be called. Exactly, correct. We can create constructor once and reuse it many times. Exactly, correct. Right. Constructor syntax is this one. This one is a constructor syntax. You can see it here. Initialization constructor, and this will be automatically called as many as time you are building the object name you're calling it here. Automatically in this line, it will be automatically triggered. And this one, what is this initialization? I have just created it with underscore INIT underscore. So this one is an initialization constructor. Take care for the double underscore. Of course, the name of the object will be self, though you cannot change it. Exactly. No. Actually, no, there is a reason of writing self here. Self is a word where we are writing, we are giving that we are calling the object name itself. We are calling the object name itself. So that's why I'm writing a self here. Okay, let me show you. Just wait here. Just wait. Suppose here roll number, name, and age is there. Just wait. You see something. Suppose here roll number, name, and age. Let me check one thing. Can I call the roll number directly? Wow, it is showing me error. You know why? Roll number cannot be accessed directly. If can I access age, name is not defined. But I can tell you that roll number and name I had written here. Roll number, name, and even age I had written here. But why it is saying it is not defined? All three things I had did it here now. It is present here now. Everything is present here. But I'm not able, why it is saying not defined? Because roll number, name, and age are the member method of, class. So these member methods cannot be called directly. Directly here, you cannot access. If you are calling it directly, anybody can tamper the data. But right now you cannot do it. They can only be accessed with object name. Stud1.roll number. Oh, wait here. It is working here. Stud1.name, it is working here. Stud1.age, it is working here. So the point is that you can access roll number, name, and age with the help of you can check it with the help of object name only. You can access it. Without it, nobody can access it. It means class gives us protection to the data. Class makes the code, member variable, member method protected. It is making it secure. It is making it encapsulated. Means here no one can access it outside. Can I use it like here? So roll number, name, and access are directly, I cannot access it. It is not working. Nothing is going to be happening here. The point is here, it is not able to understand. So the point is here, there is a threat to the data. We want to make it secure. We want to make it protected. So that's why classes are there. Class make our data shielded. Encapsulation it is making. It is never allowing any third party to grab my data directly. One has to make the protocol of making the object, and then only one can check it out. Like here, I'm making the protocol. The same one, if I want to check it out the student too, in this way, I can check it out. That is okay because I'm following the protocol. But directly, if you want to see this data, no one can see that data. Got the point here? So it means class is giving the protection to the data. Directly, nobody can do it here. Okay, this is the very simplest one here, concept here, I'm doing it here. Self we are going to use for the object name itself. It means stud1 here. Stud1 is passed into the self. Stud2 is automatically passed into the self. Okay, so that is there. Yes, we can create a multiple variables, stud1, stud2, stud3, stud4, stud5 also. But simultaneously means you have to get the code in this way only. In this way only you need to give a code. Directly you cannot give it, but here in the same way just I build up the code, the same way you have to take it here. Yeah, if you no. Not in that way. One by one code you have to check it out. Because into the self at a one time it is going to take here stud1, stud1. Then next time stud2, stud2, simultaneously not. One at a one time only. No. One can pass any number of parameters. You can pass any number of parameters. You can pass here, like here I'm writing self, roll number, name, age. You can pass any other also. Fees you can pass. Any other parameters you can pass it. Like as many as parameter we can pass it here. But not as a 50, not as a 20. But yes, few 7-8 parameters we can pass it as per the requirements here. We can do that. Okay. And simultaneously, you cannot give one at one time only, it will be working. Okay, so that is there. Yes, classes are different from the functions. Classes are totally different from the functions because functions are a member method of a class, basically. So this one is a function here. I had written a function here. I had written a function. This is a function. This one is a class. So basically, functions are member method which are written inside the classes. Okay. Functions are written here for the modularization and which are written into the classes. So class hold the functions. Class hold the variables or member methods. That is there. Okay. The use of declaring this self.roll number or is equal to roll number means we are taking inside this self automatically this constructor. I'm going to take it. This constructor will be automatically passed here. So that's why I'm writing a self. And when I'm writing here self.roll number, it means I'm passing on this value. Suppose here stud1 as a constructor I had created. So what is happening? Stud1 into the memory. There is a RAM memory, primary memory. There stud1 is created. And there this stud1 will be taking these variables automatically. So roll number will be taken automatically. But right now roll number is blank. I want to fill up with the values, otherwise it will be taking the junk values. So here this line I am giving it here. Self.roll number is equal to roll number. Okay, so here the roll number which I had passed it here, na? Suppose here 101 I had passed it, so automatically that will be passed here 101. So what will happen? This 101 roll number will be passed into the self dot roll number. So self dot roll number means stud1 dot roll number will be 101. So stud1 dot roll number will be 101. This is the use of making this line. If I won't write this line, now my code will never run. Each and every bit, whichever we are writing it here, that makes a sense actually. So whatever we are writing, that is a utility of a code we are writing. Without it, it will won't work in any case. My code will never run, my object will never execute it. So that is the way. Just wait here. Yes, exactly. Self means the program itself will take the values by using the word self, and automatically inside the self, the object name will be passed. Stud1, stud2, stud3, stud4, stud5, that will be passed automatically. You are not going to pass separately inside the self like you think, like in self you can pass stud1, stud2, no. Automatically it will take. So self is there just to take the object name itself. Exactly, correct, correct. Of course, also display in self here. No. You can never write here student. No. You can never write here in student here because self means automatically stud1 is passed. So all the stud1 values it will be taking. Stud1 dot roll number, stud1 dot name, stud1 dot age value it will be taking. And here it is taking all the values. Second time, if I'm going to call it with a stud2, so automatically here stud2 will be passed, then stud2 dot roll number, stud2 dot age, and stud2 dot name will be there. So what will happen here? This new instance name it is going to take it. Never write here. Suppose here you are thinking, can you write here student? This is a mistake. Wrong. No, this code will never run. Code will not run in this way. Okay. Got it now? Just wait, please. Just wait, please. And remember, this one is a default constructor. Just wait here. Remember, it is a default constructor here. Declaration of the student is doing, this is the name of the class we are taking it here. This one is the declaration which we are doing it here. This one is a class name. And here with the class name, you have to create the constructor. So automatically what will happen whenever I'm writing here class name, na? And here I'm creating the object name. So class name will be holding all the variables. So class name is required. Without it, I cannot do anything into the code. Means code will never run. Code is not proper. So I need to give here class name. I need to give here class name. This is a syntax. This one is a general syntax. General syntax. I have to follow. I have to write a class name. If I'm not writing, then how I will write the code? This is the methodology we have to follow. Okay. Okay. So this is the basic way here I'm just taking. Suppose here I'm writing a, is it okay now? Declaring of the student here, this is the class name, and here I need to write the class name and then object name, because this object name will be automatically understand that there is a class and there is 3 parameters, roll number, name, and age. Automatically it will search on its own. Okay, so that I have to do. Yes. In a constructor, we have to pass multiple arguments, of course. And when here I'm writing an object, there's no need to work it here because I had passed everything here. This is the standard syntax I'm following it here. Even I'm not passing a single here. I'm passing here all as per matches to roll number, name, and age. These you have to match. Okay. So let me write another code here, please. You will be getting more things here. Just you please here. Okay. Just wait here, please. Let me write here. Wait here. I'm writing an initialization constructor here. Just wait. Underscore initialization constructor here I'm writing. Then here self. Employee ID I can give it. Name, salary, I can give it. Or I can give it 2 only. So here I can give it EMP name and EMP salary. Let me write it in this the simplest way. So name and salary only I'm taking it here. Okay. So here I'm going to write self dot EMP name fulfillment. I'm going to do it here. Okay. Self dot EMP salary is equal to EMP. Oh, wait. Salary. This one I'm going to give it. Done. And now here, if I want to write a DEF, display method or any other method, you can write it here. Display data, just name change here. I'm doing it here. Print. I can write it here. Oh, wait. EMP. It is a self. Self.emp name. Okay, so these two I'm giving it here. Done. Now I need to directly, I cannot call it anything. Wait, just wait. Suppose that I'm thinking, can I directly call EMP name? It is throwing error because direct possibility is not there. If I want to call here an EMP salary, though I had built up, but I cannot call it here because it is not possible. I need to follow the rules. So it means rule means I need to follow the object name, then only I can access it. So how can I do that? Suppose I want to fulfill the first employee data. So employee 1 is an instance or object name. Then here, this class name details I have to give it. Employee 1 is the object of which class? That one is employee. And employee name and salary I have to put it. Any name here I can put it. Smith is the employee name. And any salary data here I can put it. Any salary data. It could be any salary. Done. Done. Let me run it. Done. It has executed. But how can I see it? EMP1 dot method name display data. Then only I can see it here. But here I need to give self also. Otherwise, now I need to re-execute this code. And here I need to call it. Zero positional argument here. I need to re-execute it here. Self. Now it is okay. This one is there. So here it is taking the details of the first employee. So EMP1 is the instance or object of the employee class here. So EMP1 is being called. So here automatically inside the self employee 1 will go. So object name will be passed automatically. Smith will be passed automatically here in EMP name. And this 9 to whatever salary I had given it here, that one is passed into the EMP salary. The EMP name when this line will be executed, self.emp name means employee one dot employee name is Smith. Employee one dot emp salary is this one salary here. Okay, and when it is going to display it here, it is going to check it out here automatically. Automatically EMP1 will be coming here. Then employee name Smith is going to take it here, and 925 as salary is going to take it here, which is here. So this one is the detail of first employee. I'm going to put it here. If I want to give the details of second employee, so here I can take it. Suppose Anna, any name, whatever salary is there, let it be. Done. And here employee 2, she's an employee 2, display data. This one is second employee data. Employee 3 dot, employee 3, employee, here, any name, whatever salary is there. Instance name dot, it is instance name dot display data in this way. So 3 employee data, I put it here. So in this way, your class is being constructed. There is a quite difference between the constructor and the object. This one is a constructor. Constructor is a method. Constructor is a default method which is being called automatically when an object is called. Object is basically, see, this one is just a blueprint. Class employee is a blueprint. But whenever we want to make this blueprint on the main memory, onto the memory, if I want to deploy this object, this class employee. So just to deploy this blueprint of employee onto the memory, so there I need to build up the object or instance. Without it, I cannot do that. So here I'm building up as EMP1. EMP1 is the object or instance of class employee. And whenever this object is being created, automatically a constructor or default method initialization will be called, so that the values of employee name and employee salary will be filled up with some data. So these values will be passed Smiths automatically. With the help of initialization constructor, we can fill up these values. These values will be filled up here. So these memory, the object created inside the memory will be filled up with the values. So constructor or initialization method will be, they are the default method which are helping us to fill up the variable values inside the object present inside the memory. Okay, so that one is there. Okay, so in this way, we need to write it here. Yeah, we can write it in this way. If I'm writing here, suppose EMP4 is equal to employee, and here ABC, any name of the employee, you can write it here. You can give any salary, that is your choice. Yes, you can write it. Yes, you can write any name. Yeah, you can do that. Of course, any values you can put it. That is your choice. Any name of the employee, you can give it. That is your choice. Any salary, you can put it here. In this way, you can do that. But whenever you want to do that, you can do that. And EMP, then you want to check it out the value. No, you can just write here display data. Yeah, it will be working. Does not matter as many as instance you can create it. Yeah, you can do that. Mistake, I'm doing it maybe. If you can do that. Okay. So it means 6 employee data are filled up inside the class. 6 employee data, we can do that. Okay. No, that is not required. Input data is not required there right now. Okay, so in this way we can do that. That will become much more complex. Up to here it is okay. A general understanding I want to build up, because inside Python everything is object based. See, I can understand that today's concept is little bit a higher level side, but here at least you could build up a conceptual understanding, because actually concept building is required here. Means here you need to understand. Don't think that you are going to write everything, but here a small knowledge of concept. See how we can write a class, how we can declare the variables, how we can write any functions. So how we can write the variables inside the class, how we can write the functions inside the class that is there, and how to call them. So that is the basic understanding you need to build up. Okay, that is the overall concept here. Okay. Here I'm going to take very simple steps only. I'm not going to take any complex code here. More than it. Akash, please, I'm not going to take any complexities here. Otherwise, the code will be much more complex. Okay, so the point is here, in this way, the things are working here. So you should know how to create the class, how to create the initialization constructor, and these one. Okay. Now, these are the very basic things I'm telling you. Now here, when we talk about the variables, like here I'm writing certain variables. Here I'm writing just like employee name and employee salary as a variable. So let's understand about these variables. Like in classes, when we talk about the classes, when we are working into the classes, so their variable concepts are a little bit different. So here we are having 2 types of variable. In case of oops concept, we are having a variables in 2 levels. One is instance variable. Okay. And here I'm having another one as class variable. Okay. So in variables, there are 2 types of variable: instance variable and class variables. Okay. Instance variable are those variable which can be accessed directly. Like here you can see inside the functions I'm writing the variables, they are the instance variable. Class variables are outside of functions. So let me tell you how they are working. These variables, like Wait. Okay. Suppose roll number, name, and age. Roll number, name, and age. These are these are instance variable. These one. These all are instance variable because they instance variables are associated with the object name. I can access these instance variables such as roll number, name, and age. These are instance variable because they are associated with the object. Object means self. So like roll number is associated with the stud1, name is associated with the stud1, age is associated with the stud1, or like roll number is associated with the stud2, or stud2. The point is here, I can access name, age, and roll number only with the help of object name, stud1 or stud2. So they are basically instance variable. Now here, suppose I am adding one more variable. Here I'm cutting it now. Okay, because I want to add one more variable. So that one is just like, wait, suppose here I'm making one of the variable fees. Fees is equal to, let me write it here. Suppose 3000, any value here into the fees, I'm writing it here. Okay. Done. It is working. Suppose fees is there now. This fees is there. I can write one more thing here. Okay. Let me check it out one more thing here. Fees is 3000. This is the class variable I had created. So student dot, see here, I can access the student dot fees directly also. I can access this student dot fees directly also with a class name. So basically this fees is a class variable. Which can be accessed with the help of class directly. And these are instance variable which can be accessed with the instance name only. Just wait. Wait here. Wait. Let me do one thing. Here, let me add fees is equal to see here. It is coming with the fees also. This one is coming with the fees. You can see here, I had added just self.fees also. And here I had added this fees, and here I can just check it out. The point is here, basically instance variable can be accessed directly with a class name, and with the instance name also. Fees name here I'm just taking now. So it is just displaying here. This fees, which is a class variable, it can be accessed directly with the class name and also with the instance name also. So basically in this variables, whenever we are talking about the class, there are two types of variables. One is instance variables. Instance variables can be accessed only with the help of instances, but class variables like fees I had created as the class variables. So this one is a class variable. Class variables can be accessed directly with the class name also. Instance variable you cannot access with the class variables. So this one is there. Got the point here? Okay. So Instance variables means here, remember, this roll number, name and age, they are associated with the self. So if anything associated with the self, they are all instance variable. Like here, and fees is separately. That is not associated in any instances here. So when I declare this fees, that is independent. So this is a class variable. Class variables can be directly accessed with the name of class also. So that is the key difference between the class variable and the instance variable. Directly, you can access the class variable with a class name. Okay, and direct also in this way. But these three are associated with the instance. So you can access it only with the instance name. Direct you cannot access in any case there. Okay. Okay, so this one is the key difference between the class variable and instance variable. Up to here it is okay now? That how the difference is coming between the class variable and instance variable? Like if I'm writing here revenue, any revenue is, oh, why not? Some revenue is there, revenue figure is there. So in a employee is there, certain revenue, I'm writing it here. So this revenue, if I'm running it here, just wait. If I'm running this, I can access this revenue directly with the employee dot revenue. I can access it. Directly I can access it. But employee name and employee salaries are associated with the self. So they are instance variable. They can be accessed in this mode only. They cannot be accessed directly. So this is the key difference. Okay, so in this way it is working. So these are there. Okay, just read this class here. This one, this class car is there. Just read this one, please. You can see here, I just added a few more things inside this class. Just wait here. Wait. Let me show you. Wait. See this class carefully. What is this all class about? This is a class car. Class car. I had created a constructor where company and color is the main attributes or member variables. I created the code for that and display method is here. But see, directly, see, first of all, right now, we are working in a Jupyter notebook. Let me tell you one story here. Here, we are directly writing the code inside the Jupyter notebook. But what happens? Initially, Python was created for the development purpose. Okay. Later on, data science came. So when Python was developed, it is used for the development purpose. So at that time, if I talk about 1992 or 95 or 2000, that time it was used just for only for development purpose. And there is no environment just like Jupyter Notebook or Anaconda. There is no environment. Our software is different at those timings, just like PyCharm and certain integrated development environments are there. which are only used for development purpose. There is no data science at those time. If I go 20 or 15 years back, nothing is there. No Anaconda, no Jupyter. So the way of writing the code inside those software which are related with Python development frameworks, such as PyCharm is one, IDLE environments are there, Python development IDLE environments are there. So there the writing of the code is different. Here you are writing the code in a very simplified way in data science in Jupyter Notebook right now. This is a very simple environment. But in those environment, the development environment, the code is totally different. Don't think that you are a developer, that you are going to use a development environment, but I'm telling you one thing, like history related and how I'm correlating it with the data science here in Jupyter Notebook. So basically, in those environments, there we are having a single sheet, single Python notebook, and there I have to write the entire code at once. Entire class, entire need, I have to write it here at that time. In PyCharm nature, PyCharm environment or any Python development environment. There I cannot write the code just like we are writing the code here in Jupyter Notebook. I'm writing this code here. Means in a different code cell, I'm able to write the code, but not into that development environment. In those days, I can write it. So what happened? I need to write the entire class, but just by writing the class, I cannot run it. To run this code now, to run this code, I have to write one method. You know which method? There is a main method. Inside this main method, suppose any class car is there. So here inside the main method, I have to initiate that class car. I have to initiate that class car. So the point is here, I cannot write direct code. Just like here in Jupyter Notebook, so easily we are writing it here, no? But in that environment, that is not the way of writing. So class car, I have to define. Then I have to write a separate method, main method, where I need to make the instance of this car and any other method which I want to call it. But to run this main method inside that Python development environment, I need to write one more code. Without that code, my class will never run. What is that code? That code is mandatory. That is an entry point actually. Entry point of executing that code. That one is that inside this entire file, any function is present with if name. So here we need to write that class car is there, definition main is there. So there is an entry point where I need to make it understand. If name is equal to main, it means what I'm saying, just to check it out inside this file, somewhere main function is written. So compiler will check it out. Main, yeah, it is there. So here it will say, if you find out the main function, kindly start running the main. So this is an entry point and this is a mandatory code. We have to write it. Okay, so if name is equal to main, this code will be running inside the file. This is an entry point to execute the class. It will find out that if name is equal to main, yes, is there any main function? Yes, it is there. So kindly start running that function. So the compiler will find out that main, start executing that main function. And here it will find out class car is there. Yes, class car is there. Kindly make the instance of that car and then call the display access. So here it will quickly come to run this class and the entire code will start running. So the point is here, this one is a single file we have to maintain. And here all these functions are required to execute the class. This one is a way of running in a different development environment. But here, because we are running the code inside the Jupyter Notebook, so in a very easy way, I'm going to write it here. But here I'm going to show the step all how to run the code. This one is a class car I had created just like a normal. Then I'm writing the main function here. Inside the main function, I'm going to make the instance of the class and calling the method here. Then this is acting as the main entry point. If name equals to main, it means I'm saying just to check it out here. Somewhere main function is there. Anywhere main function is there. Any function name is main? Yes. If you find it out, yes, it is there. So kindly start executing. So it will just execute the main function. It will call this main function here. And it will start building up the object of this car. And from here, it will be calling this class. So in this way, we need to write the code. This is a conceptual understanding you need to make it here. Conceptual understanding. Okay. So if name equals to main, these are the mandatory code we have to write that time. Okay. So now this is one case. So here it is going to find it out. From where the class is going to be executed here. Here it is going to check it out. The entry point will start from here. Entry point. Okay. If the code is working, if anywhere the name of the function is main, yes. So kindly start running that main. So here it is going to run the main. And here it is going to run this class here. Car C object is going to make it here. And then it is going to call the class and entire code will work. So this Ferrari and red will move inside the company and color. They will be adjusted here and then into the self.color and self.company. It will start showing here. This is a red Ferrari. So if name equals to main is the main entry point to execute any class. Okay, so and how it is written? This is a predefined code. I had not written it. This one is a predefined code inside the Python. It is there. So same I'm going to use it here. So if you're encountering this one, you are getting that, okay, it is just finding out the main function. So here it is finding out the main function. So automatically this will call this and this will be calling this one. This is a way of writing it here. Okay. No, we cannot directly call the display function here. Because if we are calling the display function directly now, then there is no use of object-oriented programming technology. Even you cannot write it. If you can try yourself directly, you try to write a display method here. Directly you can try, your code will never run. Because you cannot access the display function directly because it means you are not giving security to the display method here. You can never run. Only object name dot display method will be called. You can try it yourself whenever you are writing it here. You will never be called it here. So it means security will be finished if directly you are executing the display method. So any method you cannot call it directly because object-oriented programming system gives protection to your data. It gives security and encapsulation to your data. Python programming we can do in Jupyter Notebook, yes. Inside the Jupyter Notebook, this is a data science environment where we do the Python code. With the help of Python code, we will be doing the data science and machine learning. And there are separate environment also for the Python, but they are used for the development purpose to create the websites. So they are just like PyCharm is one of them. There are Python IDLE environment. Python integrated development environment is also there. So only development work where one is creating the website, that purpose is for that other environment. But Jupyter Notebook, Anaconda is only for the data science environment, only for the data science and machine learning, where one is going to do this data science and machine learning with the help of Python code. Okay, this is one case here. And here, you can see here, just just you can read this code. This one is an employee. Just wait here. No, this one you can see it here. Entire code I had written as a 1. Let me just make it a little bit down. Just wait here. Wait here. Wait. See this one. And I had just created a class here, name, age, sports here. So that one I had written it here. Okay, so here I'm going to write here player. Player is a class where name, age, sports will be the member function. They are the member variables. Okay, name, age, sports are the member variables, right? And then we can write the display functions. And here I can write the this one also. Here I can write the name. Name is equal to main also. So let me tell you, let me make this code a little bit down. Okay, just you can see it here. One more thing I had added here, get data also. See, see student, this initialization, initialization will be called automatically. You are not going to make a name. As soon as this P1, you are going to create it inside the main function. So when the first time you are going to create the instance, automatically this initialization will be called, and Virat 35 and cricketer will be automatically passed here. These values will be passed here automatically, and inside self P1 will be created. Whenever you are going to call the display data function, automatically here player details will be coming, and here P1 will be coming into the self. So here name, age, and sport. Name, age, and sport. So here it will be taking the value of Virat, 35, and cricket. First time. Okay. Then second time, when this code is going to execute, P1, okay, just wait. Now see the difference here. Let me tell you, wait, see very carefully now. Student, initialization is the function which is going to be called automatically. Automatically, I'm saying. This function, whenever I'm writing this one, so this initialization is going to be called automatically, but this display data is a user-defined function. So that's why you are going to call it here P1.displayData. See the differences. I'm again repeating. Display data is a user-defined function. That's why you are going to call P1.displayData. But this P1, this initialization function, this initialization function is going to be called only and only when you are going to create this P1 here. Otherwise, it will not be called. Means here, when you create the instance, so your initialization function will be called automatically. And this display data is a user-defined function. So user-defined function is going to be called how? With P1.displayData. Instance name dot display data. So all the user-defined functions are going to be called with object name dot function name. But this is a constructor. So constructor will be called automatically. See the code, if you remember, if constructor is not going, see, you are not going to call this constructor in this way, P1.initialization. You are not going to call in this way, na? Because constructors are called automatically at the time of creation of instance. And then display data is a user defined. So that's why display data, you are going to call it here. Okay. Okay, just wait. And here now, get data. Get data. So basically, get data is a user-defined function. See, wait. This one is a user-defined function. This one is also a user-defined function. User-defined functions are always going to call with just user-defined functions are always going to call object name dot function name. Always. So if display data is a user-defined function, so you have to call object name dot function name. Get data is one more function as a user-defined function I created to give new name, new age, new sport, any other name, age, sport you want to give. But how can I call it? I can only call it with object name dot function name. It means if I want to call this get data now with newer values. So here I need to call p1.getData, means object name dot function name, and then newer values I'm going to pass it. But this is initialization. This is initialization. Initialization or constructor. Initialization or constructor. Initialization or constructor are always going to call, they are always going to call automatically. They are always going to call automatically. Remember these points. User-defined functions are going to be called with object name dot function name. But initialization or constructor can be called automatically. Now you see the code differences here. When I'm going to make inside the definition being P1, so I'm only going to call this object name and the class name. That's all, and the values I'm passing. So automatically it will be triggering the initialization constructor automatically. And this display data is a user-defined function. That's why I need to call object name dot function name. So I'm writing here p1 dot display data. In this way, I'm going to write it. Because these are the rules and regulation I have to follow. So p1 dot display data, I'm going to do p1 dot display data. Now, if I want to change this value Virat 35 and cricket, I want to change it with another player. So I'm using a getData function. So getData is a user-defined function. So that's why I'm writing here p1.getData. So here I'm going to call p1.getData. Why? Because object name dot function name I have to give it. Directly, I cannot call it. If you think p1 and it will call it, that will never run even. So p1.getData, I need to write it here. Then here, new names I can give it here. Done, and then display data. So it means if I want to change this value with R35, which are default created, so I am giving it in a new value, Richard, and other values I'm going to give it. So here I'm going to trigger it again with a p1.getData. So this is first case. Done. Now, if I want to give a newer data, let's see, I want to give here P2. I want to make a P2. Suppose P2, I want to write it in. So what I'm going to write it here? Another player detail, suppose I have to write P2, this one. So when I created an instance P2, so P2 is going to call this default constructor. Dhoni 25 and cricket will be settled down in these values. And display data, it is going to show you the entire details of the Dhoni 25 and cricket. Later on, I want to change this Dhoni 25 in cricket with Vivian 65 in cricket. I want to change the value. So I had created a user-defined function getData. So separately getData function, I'm going to call it, where Vivian 65 and cricket will be coming and the newer values will be traced. So getData and display data are the user-defined functions. So we need to call object name dot function name. And initialization constructor will be called automatically. Okay, and this entire, I'm going to write it here into the main function. This one, I'm going to write it here into the main function. So what will happen? The above class is created, then main function is created, and then if name equals to main is created. This one is a basically entry point from where my code is going to start running, executing. Okay, and here if name equals to main, these are the predefined code inside the Python compiler. Automatically, when the Python compiler will read this, so it will came to know, okay, it is an entry point from where one is asking where there is a main function. It will check it out that there is a main function. Yes, there is a main function. Yes, kindly call the main function. So it will be calling the main function. And from here, it is going to call this player, and the player is going to call the entire player here. So here, this player, no, this one here, this player, it is going to call this entire player and start executing the code. Okay, so just try to see this code, read this code, and try to build up the conceptual understanding. Okay, once the concept is clear, that is okay. Even if means you are not going to do each and every code currently. Means here, but you need to build up conceptual understanding. That is required. Because in Python, everything is a concept, everything is a class-based, everything is an object-based. So that is there. So just to try to read the code, try to build up the conceptual understanding. Though the things are a little bit high, I can understand today the code is a little bit higher level, but here still you need to try to understand the conceptual code, okay? Because if you want to become a data scientist, of course, you need to understand this thing somehow. So just see here how I'm writing the code, try to understand, read it, just wait, I'm taking questions. P1 and P2 are object or instance of the class. They are instances of the class. No, here, no way I'm duplicating P1. There's no way I'm going to, it is, I just change the, I'm not going to duplicate it here. This is the same P1, no duplication is there. Here I'm making the fill up of the values and here new values I'm giving it. There's no duplication, no. It will not give the error. There's no duplication into the code anywhere, no. Just wait here. Please wait, just wait, please. Let me check out the wait, please, please. See, wait, students. See, I had told you one thing. When during the class, please do not write the code. Same thing I'm telling you continuously because what happens now, you will start writing the code and 100% errors will be there. Because something you will be missing in between. Why? Because your pace is different. You're not able to write at that pace. So that's why I ask you, do not write the code at that time. You just listen to me. If any doubt is there, you can ask. Later on, once the video is uploaded, at that time you can write the code. Because at the time of video you are having, you can stop the video. You can write the code. You can again rerun the video and again you can rewrite the code. In that way, now you will be into your pace, the speed of writing. If you write it here into the class, now 100% you are listening to me and then you are writing and errors will be there 100%. Avoid these practices there. Okay, so that here. Okay, just wait here. Wait, please. Just wait, please. Just wait here. I'm re-explaining here. If name equals to main, you need to wait here. Just wait here. Wait here. No duplication is there. I told that instance and object are same. Instance and object are same. There's no difference there. Just wait here. Please wait. Let me wait here. Ma'am, can I execute without using? Yes, you can write here P1 is equal to, just wait here. Just wait. Yes, you can write here, wait. Ma'am, I can execute P1 is equal to player without using the EF main function. Okay. Yes. You can execute P1 is equal to player without writing here main function. Yes, you can do that. But what I'm saying you, even if you won't write this main now, directly, just wait here. If you won't write this one, so you have to take all this code this side, just indentation, you don't need to give it, and that will start working. That will start working, exactly. I can do that, okay. If name equals to, but here why I'm writing this main now, I told you that exactly class structure is written in this way. That earlier I'm doing it because we are writing into the Jupyter notebook. That one is a data science environment. So in Jupyter notebook, there is a possibility of not writing even def main and directly I can write the code. But this one code which I'm taking now, this one is the exact syntax of writing any class. This is a proper syntax. Okay, so you should know that if name equals to main is basically, let me tell you again how I'm writing it here. If underscore underscore name underscore underscore is equal to underscore underscore main is underscore underscore wait this one. This is the code I'm using it. If name equals to main, what does it mean? I'm re-explaining. If name equals to main means here, I'm saying that inside this entire code, you find out this one is actually entry point. This one is the entry point in any class. This is the exact code of writing a class. If name equals to main means here that inside this particular class, anywhere, main is there. Anywhere, any function is with main. Anywhere, any function is written with main. So, yes, function is main, exactly. It will just check it out. Function is main. So if main function is there, so yes, we had find out main function. So kindly start running this main function. So it will come, the compiler will come here to main and it will start executing this main function and this all class instance it will start creating. In this way, this main is working. Okay. Okay. No, name is not a function. Name is not a function. It is saying any name of a function is main. Name is not a function. It is saying any that inside this entire code somewhere main function is there. It is saying any code is there with a name function. Any code name, it is saying any function name is there. Function name is there with a main. It is saying this name is present. So here it is looking main. Yeah, it is there. So start running that main. This is that. Name is not a function name. It is saying any name is present somewhere with the main function. That is there. Okay, so that is there. Okay. So in this way, it is going to run it. So up to here, it is okay now. Have you understood the basic conceptual understanding you need to build up? Thank you. Yes, yes. In this case, both data will be saved into the primary memory, RAM memory. Exactly. Right, right. Okay. Okay. No, but still we have to complete our class, na? Yeah. Yes, to become a data scientist, you have to digest a lot, of course. But here, now, this is the only class I'm taking a very little bit higher level. Now I'm coming again to the lower side again. Okay, if you understood it now, so that is okay. However, conceptual understanding built up, you need to do. Okay, now I'm again coming to the lower side now. Okay, so sum up, sum down, we have to clear that. Okay, so this one is a class concept we had built it. Okay, so now what happens? Uh, okay, I got your point that today's class is a little bit complex here. Of course, to be a data scientist, you need to understand the Python properly. Of course. Yeah, concepts you need to build up. You need to know how to write the codes here. Okay, so that is there. Of course, you can understand that. That is good. You need to work a little bit harder side, little bit slight side that you need to do. Okay, so here, let's understand next now. So we developed understanding of class, objects. Okay. So you think it, suppose here, I'm having one of the file, just to think it here. There, I am having one of the file name here. Suppose here I'm writing one of the file here, just like my module. You think it, suppose I'm writing one of the class. Sorry, just wait. Please wait. Okay. Suppose here I'm writing one of the class here. My module, and here what I'm doing, I'm writing here certain classes. I'm going to write a class A. And here I'm having function definition, okay, such as def, any function 1, certain codes are there. Def, function 2 is there, and corresponding codes are there. Let's take another class. Suppose here class B is there. Def, F3 is there. Class B is there. Inside the def, class F3 is there. Def, F4 is there. Then there is a class C. Def, F5 is there. Okay. Now the point is there, means here I had created a multiple classes. Corresponding functions are there. Now you think it. Suppose I'm writing one more code. So here I'm writing one more code. Another class I had opened, another Jupyter I had opened. Whatever code I want to write inside this Jupyter now, that code is just similar to this F1. That code is just similar to this F1. So one thing I can do it, I can rewrite entire definition. Suppose here I had written 20 lines of code here. So I opened a fresh Jupyter notebook and I started writing the entire 20 lines of code. But if I start writing it, what is the use of computer science? What is the use of writing a code again and again? The primary objective in computers is to save the memory. More and more, if we save the memory, my code will execute fast and I can save much more data here inside it. So we should reutilize the code inside any computer science environment. That is the major benefit we should track it. What I will do, instead of rewriting the code, I will say, already I had written a F1 code with the entire 20 lines. Why not to reuse it? I want to reutilize it. So simply what I will do, I will just call this module here. I will just call this so that I can reuse this. How? I will use a keyword here, import. Import my module. This I'm going to reuse here. Okay. So once I'm using this one, the import keyword will call entire classes. inside this file here. But I need to call only one. So here I will write, listen, import my module. Entire classes will be available into this Jupyter notebook. Now here I need only this class A F1. So here I'll write from my module, import is a keyword. It is import T, it is import A. Means from this my module, import this class A. This one is the class A. Got the point here? Import A. So automatically class A will be present here in Jupyter notebook. Got the point? And here, if I want to use this F1, so simply I will write one code here. A instance here I'm making for what? For this class A instance I'm making, that A dot F1 I will write it. What does it mean? With import module, I can just carry on this entire code inside Jupyter notebook. From my module, import that A class, I can call it. And then A instance, I'm making it here, then calling the F1 function, and that will be executing automatically. So it means import keyword is there through which I can call this library. So I can call it another way. These are basically libraries. Library means a set of different classes are there inside one Jupyter notebook, basically. So basically here, in with import, I can just call this. So it means inside Python, inside Anaconda here, I can say, there are so many built up classes are there. Okay, so if you think, suppose here, I say, this is a module 1. This is a module 2. This is a module 3. So these are modules or library, you can call it. And here, class A, class B, corresponding functions are there. Class C, class D, and corresponding functions are there. Class E, class F, class G, class M, class N, and various class up to Z, you can create whatever number of classes. So here we are having different modules or different libraries, you can call it. They are present. Okay. And they are all packed into the packages or sub packages. So they are present here into various packages. Just like number of modules or number of libraries are present inside packages or sub packages. Just like, you are having folders, subfolders. Inside the subfolders, you are having various files. Inside the subfolders, you are having various files. So in a similar way, we are having files of entire classes, those libraries we are having, all those modules we are having inside the packages or sub packages. So they hold these modules, and whenever we need to call these modules for our purposes, any purposes, we can just call with the import module name, and then from there we can grab out any class. So basically inside the Python or Anaconda, you can say Anaconda, we are having thousands and lakhs of packages and modules and classes are there. So many modules are there inside there. There's so many classes. So whenever we want to use that, we can call it. Okay. So we can call them. So basically there are packages are there, inside packages, sub packages are there, and inside there are a lot of modules, and inside those modules, classes are present there. Got the point here? So that we can take that here. So here, if we want to call any module, suppose I want to call any module here, Just wait here. So how can I call those module? Simply, I am going to call that module with here. I'm going to call the modules with import keyword, import. So here I'm going to call the modules with import keyword is there. Suppose keyword is there. This is one of the module keywords. Suppose I want to see what are the keywords inside the Python. So keyword dot kw list. Some are directly. This one is there. Import keyword module. I'm just calling it here keyword dot kw list. So here it is just showing you keyword list. So can you see here? False, none, true, and break, class, continue, def, del, elif, else, for, import, if, so many like pass, lambda functions you had used, return, while, so a lot of things you had used. These are the various keywords present inside the Python here. Keyword list it is going to give you. Now suppose here there are certain more modules are there, predefined modules are present here. Let me check it out, please. Please, just wait here. Just wait. There are certain keywords such as sys, import, sys. This will be showing me the system path, sys.path. So import sys, this is one of the library or module. And inside there's one of the attributes sys.path. So here it is going to show you that where your Anaconda is installed. So here, when you will write, you will be getting where your Anaconda is installed. Okay, means that path it is going to show you all the folder, subfolder that is going to show you. There's one of the module here, import as it is. Just wait here, let's know small things. OS dot, if I want to see what is the here, get current working directory. It is get current working directory. Import OS means import operating system. And inside the operating system, I want to see what is the current working directory. There is a method inside the operating system. What is the current working directory? So here, current working directory, if I'm looking at here now. So here it is saying the current working directory C drive users del. So what is this directory? Means wherever your current home directory is running for this entire Anaconda, wherever in your PC it is installed, that current working directory it is going to show. Okay. If I want to see here list directory, that inside this operating system, show me list of directories. Just wait here. It is I just forget certain list of directories, that what are the various list of directories you are having. So here it is showing you operating system dot show me entire list of directories. So it is going to show you that whatever is present inside your current home directory, where your Anaconda is open. So all the files will be listed here. Files and folders will be listed here, whichever is present inside your current operating system, current working home directory, wherever you are present inside your Anaconda. Okay, so that will be there. Now, okay. Now suppose here, you know, there's one of the library, very important library, import math. There's one of the library math from where I can use math function, math.py. Suppose here, math.py is one of the attribute I want to see what is the value. Here it is going to show you 3.14 is math.py. I will be using it here. Suppose here, I want to find it out. Area of a circle. Area of a circle is a pi r square. So I can use the math.py. Area of a circle is a pi r square. So if my radius is suppose here 90, let me take it out. And if I want to find out area of a circle, so pi r square now, so I can write here pi value, I can take it from here. Pi into radius into square now, it is there. So math.py value, I can use it. in this way. So area mat.py value, I can use it in this way. Suppose here I say that I want to see mat.power function. So power function, directly if I use it here 2 raised to power 2 or 5 raised to power 3, I want to do that. So this one is the base. This one is it's power here. How can I use that? Here inside math, there is one of the function written here, math.pow. It is W. Instead of this math.pow, here I need to write the base and the power. So here you can write base and power. This one is the general syntax. Base and power, you have to write it. So instead of base, here I need to keep the value. Suppose I'm writing here 2 and power here I'm writing 2. So 2 raised to power 2. So math.power, here it is giving 4. Math.pow power function. Here I can give you suppose 5 raised to power 3. So 5 raised to power 3, it is 125. Suppose here math.power function, power 8 raised to power 2. It is 8 raised to power 2. So it is 64. So in this way, it is going to give you power function. Okay. There is one other function inside the math.sqrt, square root. Suppose I'm giving what is the square root of 64? It is 8. Math dot square root, any value you can give it here, like 144. Oh, it is 144. So 12 is the square root. So basically all these are built in inside the math, like pi, power, square root. There are certain more functionalities also. They are related with certain entire geometry, like tan, sine, cos theta, tan theta, sine theta, radians, entire those values also we can use it. It means whatever inside the math we are doing it here, we can take it here, we can just put it inside the formula. So these are pre-created. So like in Python, everything is object-based. Inside Python, everything is class-based and object-based. So we can call it. Everything is inside Anaconda, it is there. Lakhs of libraries are there. Directly I can call it, I can use it. Entire data science, I'm going to call these things. So math.square root, math.power, math.pi, in this way it is there. Suppose here directly I'm calling the math here. If I want to take a short name for that, how can I take the short name? So for that, simply what I'll do, I will just write here, import math as M. M is a short name, nickname. So now I will be calling m.py, m.pow, power of such as 9 raised to power 2. Everything I'm going to give the M. Means I had just created a nickname, short name, alias name, nickname. M.sqrt, and here I can give any number here I can give it in this way. So with a shorter name I can work with. Got the point? Okay. Now, whenever I'm writing here import math, all the functionalities or all the related code written inside this math will be appear into Jupyter. But I do not need that. I need only one function. I do not want to call entire. So whenever I want to call a single, only one. So what I'll write here, I'll just write here from library name and that particular function name I can call it. I'm saying that only I need a power function. I do not need any other. Whatever is with you, keep it with you. I need only power. So simply I will be calling it here. And then I'm going to use POW, means that function name, and any value here I can give it, such as 7 raised to power 3, any power function I can give it here. Got the point here? So only whenever I want to call single functionality from any entire library, so I can call it here. Like here, 6 raised to power 3, anything, means whatever you want to do. So the point is here, only single functionality I want to call it here. So only that function name I can call it from library name, import that particular name. Okay. Rest, this is a alias name I created, and rest, this one is the simplest way. then I can call it with the import math here. SQRT is there. No, you cannot call it for the short name for the functions, only for the library name when I created import math as M, so that you can do that. Otherwise, you cannot do that. Just wait. Okay, so this one is there. No, still Python is there. I need one more class also for. I'll ask my team just to change the center, please. One more class I need it. So these are the ways to write it. So these are the same here. Okay, this command, you can use it. mat.__dictionary.keys. If one wants to see what are the various functionalities available here inside math. So basically, these are all related with the trigonometry. It means tan, cos, theta, sine, theta, all these things are there. You are not going to use all those things, but I'm going to show you that. Okay, but the rest of the things are the same one. Okay. This is there for the today. So you had learned this how to work with the classes, how to write the code with the classes, how to call the import statements. These are all very basic things you must understand. Just wait. Up to here, it is okay now. So these are the basic commands. First, to practice these commands only. Okay. So that's all for today. SQRTR2 for square root. Is it okay? Thank you. Thank you very much. You need to revise this class because we are coming to the higher side of the code now. So at least one more time you watch out this video and then you write the code. The things will be clear. Once you start writing the codes on your own by watching out the video, because you can stop the video, you can write the code at your pace actually. You can start the video, you can stop the video, write the code. Slowly it will be cleared. But yeah, today's class is a little bit complex. I can understand because whenever we start with the class concept, whenever we start with the oops, this class is always a little bit complex side, high level side. but still, at least 1 or 2 classes if you write on your own, a basic conceptual understanding, you will be building it. And somewhere you are able to understand. But don't think that every time you're going to write these things. These are just because like here I'm going to use it, import math, math.py, math.power, and so many math commands I had used it. You think if I'm not conveying you that what is a class, and directly I start writing this code import math, though this is one line, very easy. So you will say, ma'am, how you're writing this import math, math.power, from where it is coming? Anna? So from where it, what is the source and how it is understanding these things. So just to understand this one line, we need to build up the code for entire classes, because there's a complex code written in the backend. And then here we are going to import all these things because they are all class-based basically. And in entire data science, we are having a libraries. In Anaconda, lakhs of libraries are there. So in Python, in Anaconda, everything is object-based. Okay, so that is there. Akash, here you are going to see my video again. Then you write your code. You stop the video, then you write the code entirely. And once you will be writing the code, then you try to run. Once you are going to run it, you will be getting what is the error. If the error, because most of the errors, 99% error will be removed automatically when you will be watching out the video and writing the code there. And still, if it is there, then you can just tell to the chat and it will be clear to you. Thank you for today. Thank you very much. Thank you.